All right, in this lesson here, we're looking at straight line motion revisited. So we've looked at this before, but now we're going to look at it from an integration standpoint. So when we examine straight line motion in our derivative section, we generated a relationship between position, velocity, and acceleration. Given position function s of t, the velocity function v of t, and which is the same thing as s prime of t, and the acceleration function, which was a of t, which equals v of t, which also equals s double prime of t. Now, we can move in the opposite direction as well. You can have an object traveling along a straight line. Its velocity can be written as v of t is equal to the integral of a of t plus c. And its position can be written as s of t, the integral of velocity function of t plus c. So let's take a look at these first problems here. Number one here, find v of t if a of t is equal to 4t minus 6. And v of 0 is going to give us 3. So we start here, we're looking at v of t, and we're going to integrate it here as we have 4t minus 6, of course this is dt. Now, as we integrate this here, this is going to give us 4t squared, so 4t squared over 2 minus, this becomes 6t, so this becomes now 2t squared minus 6t. And this is equal to, this is, of course, our v of t. So what we're going to do now is we want to solve for c. Now this would be plus c here. So now we want to do a solve for c. Well, we know v of 0, okay, is going to be 3. So if we plug 0 in here, we get 3 is equal to 2, 0 squared, minus 6 times 0 plus c. Well, these cancel, leaving us that c is equal to 3. So therefore, we have our velocity function as 2t squared minus 6t plus 3. All right, so let's take a look at the next one here. Find the velocity function if a of t is equal to sine t plus 2t, and v of 0 is going to be 5. So we integrate here. This becomes we're once again looking for velocity function. And this is going to give us sine t plus 2t, and it's going to be dt. So in this case here, we integrate here, which is going to give us a negative cosine t. This will give us 2t squared divided by 2, which is going to give us just t squared, so plus t squared plus c. And then again, v of 0 is going to be 5, so we're going to plug that in for v of 0, and then we're going to put negative cosine of 0 plus 0 squared plus c. Well, cosine of 0 is 1 times a negative gives us negative 1, so we get 5 is equal to negative 1 plus c. Add 1, and c is going to be equal to 6. So therefore, our velocity function is equal to 6 minus the cosine of t plus t squared, and we've got our c over here at 6. Remember, sometimes they will rearrange that because they don't like to lead off with a negative function. But it's not wrong if you put the 6 at the end. So let's look at the last one here. So find v of t if a of t is equal to e to the t plus t. So once again, we will put v of t equal to the integral, and that is an awful integral here, but we'll go with it anyway, e of t plus t dt. Now, v of t is equal to, so integrate e of t, and then that's just going to be itself here. So that's going to be e of t, and then we're going to have t squared divided by 2, so we'll have t squared divided by 2 plus c. Now, we know that v of 0 is going to be negative 1, so we'll put negative 1, we'll make this e to the 0 plus 0 squared over 2 plus c. So this gives us a negative 1, this becomes 1, and then we have plus c, the other one's 0. subtract 1, and that's going to give us a negative 2 is equal to c, which gives us v of t is equal to e to the t plus t squared over 2, or 1/2 t squared, and then we put minus 2. So kind of just a refresher there. Okay, now this will be the same true if we're trying to find a position function, starting with the velocity function. And if we were going to look for the position function here, we would just take the antiderivative of any of our functions, of our velocity functions here. So now let's look at this next part. We now define two terms, displacement and distance. So these are can be confused. So displacement is the difference of the distance between where you start and where you start. Start and stop, reverse that, okay? So the distance is how far you travel between time A and time B, okay? So displacement will equal the distance when you're always moving in the positive direction. So if you look here at the diagram, you start here, you're going to travel 80 miles to the right, turn around, and you're traveling 60 miles to the left, and then you stop. Well, your displacement would be 80 minus 60, which would give us 20 miles, okay? Think of it as how far from where you started. The distance you travel, well, distance is always going to be positive, so you traveled 80 miles, and you traveled 60 miles, okay? So if you're kind of think of it as a car, you're driving, you're still having to travel 140 miles. So you got to make sure you have enough gas. It's not like you're only going to travel 20 miles because of the displacement. So remember, displacement can be negative. Okay, depends on it's about your relationship to where you start. Okay, and your distance is always positive, so you're always going to be adding up those values there. So if we're given a velocity function, which is always positive, okay, we know the distance is going to equal displacement. But if the velocity function is not always positive, we must find the time interval when the velocity function is negative, which means the particle is moving backwards. Okay, so we can find the distance traveled in that interval and subtract it, which will be subtracting a negative number or adding a positive one. Okay, so this can be summarized in this picture right below. So given a particle moving in a straight line with a velocity v of t on a time interval ab, the displacement is going to be the integral from a to b of vt dt, and the distance is going to be the integral from a to b, but it's the absolute value of vt dt. Okay, so let's take a look at our first one here. The particle is moving along with the velocity v of t is equal to t squared minus 7t plus 10. Find the displacement on the interval from 1 to 7. Okay, so we're looking for the displacement here. They give us the velocity function here, so it means the s of t, we're looking for the position function, is going to be integral from 1 to 7 of t squared minus 7t plus 10, okay, and this will be dt. So we'll take the integral. So this is just easy function to take the integral of. So remember here, as you take this, this is going to be, we're going to add 1 and divide by that number. So this will be t cubed over 3 minus this will be 7 halves t squared, or you can do 7t squared over 2. This will be plus 10t. And remember that the plus c is going to cancel out because this is a definite integral. So we're just going to evaluate this from 1 to 7. So to kind of refresh your memory here, we're going to put 7 in for t, and then we're going to subtract the function when we put 1 in for t. So as we start here, we're going to have 7 cubed over 3 minus 7 halves over times 7 squared plus 10 times 7. Okay, and then we're going to subtract. So we're going to get all this, and then we're going to subtract. We get 1 cubed over 3 minus 7 halves times 1 squared plus 10 times 1. So, and you can do this however you want. You can change your denominators to be the same at the beginning. You can, it's easier to add and subtract when they have the same common denominators here. So 7 cubed over 3 is going to be 343 over 3. Then we're going to get 49 times 7, which is the same thing as 7 squared. It's going to be 7 cubed, which would be 343 over 2 plus 70. Okay, so now we'll continue this. Let's put them all in the same denominator, which makes it easier to work with. So this, we'll put it into 6. So this go 686 over 6 minus 1,029 over 6. Just making equivalent fractions and multiply by 6 here, which gives us 420 over 6. Evaluate all this here. Of course, this is still just doing this side here. And this is going to give us all the way down to 77 over 6. Okay, so now let's do the right side. We get 1/3. So we get 1/3 here minus 7/2 plus 10. Now common denominator, which would be 6 again. That way everything's easy to add and subtract at the end. So that's going to give us 2 over 6. This will give us 21 over 6, and then 60 over 6. Add them all together. And once again, remember we are subtracting here, so set our brackets up. Those are awful brackets, but you get it. All right, so now we're 2 minus 21 plus 60 is going to be 41 over 6. And we subtract this value here, which is going to give us 36 over 6, which is equal to 6. So our displacement is 6. All right. So now let's look at the next one, number 5. Okay, so particle moves along with the velocity of the same velocity function. V of t is equal to t squared minus 7t plus 10, but we're going to find the distance it traveled from 1 to 7. So in this case here, we have to know where it's going to be positive and where it's going to be negative. So one way to do this, okay, is to take our function here and find the zeros to start off with. That way we know kind of what to integrate. So what we're to begin with, kind of what we're looking at here is we're doing s of t is equal to the integral from 1 to 7 of our absolute value here of t squared minus 7t plus 10 dt. So the first thing we're going to do is we want to factor this, kind of see what our zeros are. So we're going to factor this down here, and we're basically going to set this equal to 0. So this becomes t minus 2, t minus 5. Okay. So find our zeros here. That gives us t is equal to 2 and t is equal to 5. So another way to do this here is to take a look at it as these are our critical points. If you remember critical points here, so we can test these critical points to know where is it going to be positive, where is it going to be negative here. So let's do this real quick. We're going to start with 1. So we're going to go from 1 to 2, from 2 to 5, and from 5 to 7. So we kind of know what's happening between these two. And so you can plug these in, pick a point between them, okay? And so you could do 1.5, plug it into your function here, and see if you're going to get positive or negative values. So in here we get positive between 1 and 2. Between 2 and 5 we get a negative value here. And then between 5 and 7 you get positive. So you could also, if this was a calculator problem, you could graph it and you could tell where it's going to be below the x-axis, where it's above the x-axis. But now we know that we have positive here. That means we're going to, as we start to work our problem here, okay, so we're going to have to break this apart into positive intervals and negative intervals. So this becomes an integral here. So this is all s of t here. This is going to be, we're going to go from 1 to 2 because we know it's positive of our velocity function here. Okay. So to kind of give you an idea, we're doing velocity function here. This is our s of t. So we got 1 to 2 dt. Okay. Then we're going to subtract out, okay, our integral from here. So we know this is negative, but so in order to make it positive, the way we treat the absolute value is we subtract it, because we're going to get we know we're going to get a negative value in this from 2 to 5 of a velocity function. So therefore, by putting a negative in front, it's going to ensure that it becomes positive. And then the last one here we know is positive from 5 to 7. So now we're going to take our function and we're going to evaluate it. Okay, and the math is, there's a lot of work in this and a lot of math involved, a lot of fractions. It's not a pretty problem. Okay, so but I want to make sure that you understand why we're subtracting here this integral in the middle. And basically what we're doing is we're adding up the positives and we're subtracting the negatives so that it gives us a positive value. So because we're looking for the distance, not the displacement. Okay. Displacement, we could work it all the way through. We could just work it through and it would work itself out like it did the last one. So now, let's take a look here. We already know that we already know it's going to be t cubed over 3, okay, minus 7 halves t squared plus 10t. This one's going to be evaluated from 1 to 2, okay. And then we're going to subtract, okay, as we do t cubed over 3 minus 7 halves t squared plus 10t. We're going to evaluate this from 2 to 5. And then we have our last one here, which we know is going to be t cubed over 3 minus 7 halves t squared plus 10t. And we're going to evaluate this one from 5 to 7. All right, so pause your video, work this out, and then come back and check your answer when you're done. All right, so let's see how you did. You should have gotten 15 for your overall answer. So if we look at each section here, I put it in blue so we can kind of separate it here. Now the first one we're going to integrate. As we integrated, we got our integral here, and we're going to evaluate it from 1 to 2. So this first one here, you kind of have to do most of the work here. But we can also use, because we've used 1 up here, because this is the same function we did before, we know when we evaluated 1 up here in the last problem, we got 41 over 6. So we know the right side, as we evaluate it for 1 here, is going to be 41 over 6. So this part right here is what I'm talking about. We can use that from this, what we got up here at the top. Now, this one here, we get 8/3 minus 14 over 1 plus 20. And then because they're in thirds here, we want to put them into 6, which is what our last problem was. So we'll put all this into 6, which gives us 52 over 6 minus 41 over 6 gives us 11 over 6. Now the next part, we're going to, as we integrated from 2 to 5, okay, so we plug 5 in here. We're subtracting this whole thing, so we're just keeping everything separated. We get 125 over 3 minus 175 over 2 plus 50. Now we know 2 already because we just did it. We got it over here to at our left in our last problem. We know what 2 is going to come out to be 52 over 6. So that's what we're going to subtract here. Get everything into 6 over here, which gives us down to 25 over 6 minus 52 over 6 gives us a negative 27 over 6. Now remember, because we're doing distance, it's got to be positive. That's why we take the negative here, and that'll make it end up being positive. And the last one here, we're going to evaluate from 5 to 7. And because we've already done 5 and we've done 7 from the last problem, and 5 from this last part of this problem we did, so we know we're going to get 77 over 6, and that's referring to this right here. Got 77 over 6 here. So 77 over 6 minus 25 over 6 gives us 52 over 6. And now we're going to add all 3 up, which gives us 90 over 6, which comes out to be 15. So, yes, there's more work here. You got to find out where your problem is going to be negative, where it's going to be positive, and that's one way to do it. Finding those critical points, finding and plugging those points back in. So let's look at number 6 now. A particle moves along a straight line with acceleration at is equal to the square root of t feet per second squared. Velocity at 0 is going to be a negative 18. So which means our t, when t is equal to 0, okay, and then we're going to evaluate this from t is equal to 0 to t is equal to 16. So express your displacement and distance that the object travels using integrals without the absolute value, and use your calculator to find your answers. So before we start this problem out, we know that the v of t is equal to the integral from the square root of t dt. Now, we're not going to put in boundaries yet, because what we're doing is we need to get this. This is our acceleration function here, so we need to get this down to our velocity function. So we need to find this first. So v of t is equal to, now if we evaluate this, remember this is going to be to the 1/2. So we're going to add 1, which gives us 3/2. And then we're going to divide. So this becomes t to the 3/2 divided by 3/2, okay, plus c, which gives us v of t is equal to 2/3 t to the 3/2 plus c. Now, we said that when v is when time is equal to 0, the velocity is going to be -18. So we put -18 in here. So we get, this becomes 0 to the 3/2. And then we're going to get plus c. So this means that c is going to be a -18. So our velocity function, which is what we had to find first, is going to be 2/3 t to the 3/2 minus 18. So now we're going to use this. So we're going to start with to find the position function. Okay, we're going to evaluate from 0 to 16, and we're looking for the displacement. So we have 2/3 t to the 3/2 minus 18 dt. So, once again, integrate. We're going to add 1, which gives us 2/2, which is 5/2. So we're going to add, we have 2/3 here. We're going to have t to the 5/2 divided by 5/2, which is the same thing as multiplying by 2/5. So if I bring this up to top, this becomes 2/5. Okay, and that gives us 4/15. So we get 4/15 t to the 5/2. Okay, and this is going to become minus, and this becomes 18t. So I probably should have done this earlier. Okay, and now we're going to evaluate this from 0 to 16. So as we plug this in, this gives me the square root of 16, which is going to be, well, let's see if we can get this here. So the square root of 16, which is 4 to the 5th power times 4/15 is going to give us 4,096 over 15. And then we have 18 times 16, which is going to give us a negative, so minus 288. Okay, now because we're starting at 0 here, this is going to make everything else 0, so there's nothing to subtract. And so as we evaluate this, we're going to get a negative 14.93 repeating. Okay, so this is how many feet. That's the displacement. Now, so now we're going to use the calculator here. Show you how we do this. So S of t is equal to, and this will be from 0 to 16. So in your calculator, you're going to put in the absolute value of t, or 2/3 t cubed, or t to the 3/2, sorry, minus 18 dt. Now, when you plug this in your calculator, this is going to give you S of t is equal to 179.46 repeating. Now, to also illustrate this, we're going to use our calculator, but we're going to kind of break this apart here. If you look at the graph of this function, okay, you're going to see that it starts off below the x-axis here at 0, and it's going to go up and it's going to cross at 9. So that means that this integral from 0 to 9 is going to be negative. So we have to find the distance, we have to put a negative out front. And this becomes of 2/3 t to the 3/2 minus 18, okay, dt. And then we're going to add the integral here, and this becomes from 9 to 16. of our velocity function here. So just to save room to write them, put the velocity function that we have, dt. Okay, so that's going to give us a negative 97.2. I think multiple zeros here, and then we're going to add, which you get 82.26 repeating. That's what you get for the second from 9 to 16, which gives us the 179.46 repeating. So anything that's below the x-axis, remember in the velocity function, you have to when you're talking about distance, you have to put a negative out front. All right, so let's take a look here at our next problem. All right, so let's look here at number 7. So a subway train accelerates as it leaves one station and then decelerates as it approaches another. The following table measures the velocity in miles per hour at 5-second time intervals. Okay, so part A says find the distance of the train travels every 5 seconds and complete the table. So we'll kind of do the first one here. So what we're doing is we're going to use the trapezoid method. So using trapezoidal method. Because we don't have a function, we are using information on the table. We have to have a way to do this. So what we're doing is we're going to do 1/2. Trapezoidal method, remember, is 1/2. You're basically taking the trapezoid. Okay. Now the height of the trapezoid is a distance here, which is the 5-second interval. So we're going to have 5 seconds. Now, one thing we have to do here is this is in miles per hour and we have it in seconds. So we have to convert here. So this means it's going to be 1 hour is to 3,600 seconds. That helps us get our conversion right. Okay. So then we have the distance here between our velocity, which is going to be in the first one 0 to 15. And the next one you go from 15 to 33. Okay. So once you get this value here, of course the first one's going to be 0. The next one's going to be 0.010. Okay. And so what you're going to do is you're going to continue this out. So like I said, the next one we'll set up the next one. We got 1/2 times, this is going to be 5 over 3,600 seconds. So we're getting that conversion there. So the next one is going to be 15 plus 33. Okay, and that's going to give us 0.033. So we're just going 3 places throughout here. So continue this on, and that's going to give us here, so we'll kind of save time here, we're going to get 0.052, 0.060, 0.061, and I would encourage you to calculate several of these here to make sure you're calculating correctly. And then we get 0.060, 0.053, 0.043, 0.025, and 0.006. Okay, so now find the total distance between subway stops here. So we could use this. This is the distance here, the ones in decimals here at the bottom. We got to add them all up, or we can use our trapezoidal rule, which says we're going to do 1/2. Okay, then we have to have the conversion here. It's the height here, so it's usually h over 2 if you remember that. Okay, kind of write this here. We have trapezoidal rule was h over 2 times y sub 0 plus 2 times y sub 1 plus 2 times y sub 2 plus 2 sub y sub 3. Okay, we get 2 to the n minus 1 plus y to the n. So the first and last are always just the single term, and then everything else is multiplied by 2. So in this case here, our height is going to be the same thing as we did before, the 5 over 3,600. That gets our conversion factor. Then the rest is going to be 0 plus 2 times 15 plus 2 times 33 plus 2 times 42, and so forth, and we get plus 2 times 8 plus 0. Add all this up, and this is going to give us 0.526 miles. That's the total distance the train has traveled. All right, so that concludes our lesson on straight line motion revisited.